In earlier videos, you learned that the FlexMX architecture intrinsically ties the behavior, layout, styles, and skins of a component together. The Spark architecture, on the other hand, explicitly decouples these elements to add more flexibility to your toolkit. In this video, you will learn how Spark lays out components using the layout classes. You will also learn how these layout classes can be applied to the Spark container classes to give you fine control over your application display. There are 4 Flex Framework layout classes: Basic Layout, Horizontal Layout, Tile Layout, and Vertical Layout. The Basic Layout class will display all the content in a container based on X and Y absolute properties. The Horizontal Layout class will place all content horizontally next to each other. The Tile Layout class will tile all the content children of the container, and the Vertical Layout class will lay all of the content children vertically relative to one another. You will learn more about containers in a bit, but for now, know that each container has a layout property. The layout property, as shown in this code, is usually added as a nested node in the container. You can tell that it is a property, not a class, because the word layout is not capitalized. Inside the layout property tag block, you add an instance of one of the layout classes, like the basic layout class in this case. Let me be clear that basic layout is a class implementation separate from the application container. The layout property of the application container is specific to the container, but the basic layout class is an instance of a layout class applied to this container. Again, this speaks to the Spark architecture for separating layout from functionality and content. Here's the code for the starter file and the associated exercise for this video. It includes a text header display that reads employee directory and also 4 instances of the employee display custom component. You will learn how to create custom components of your own in a later video, but for now, just treat them as if they are any other Flex component, but in a custom namespace called components. Note that there are 4 additional instances that are commented out for later use. When I run the application, you can see that the components are displayed diagonally from top left to bottom right. When I return to the application code, you can see that the component instances have X and Y properties that explicitly set their absolute position on the screen. By default, the application container implements the basic layout class to lay out its children. The class uses absolute positioning, which requires that each of its children specifies an X and Y property that is based on an origin or 00 point in the top right corner of the container. This illustration shows that the X value increases to the right and the Y value increases down the display. I have located the properties of the parent comment and am creating a layout property for the application container. I am typing and opening angle bracket to start my MXML code. As I start to type the word layout, the Code Assist tool suggests some options to me. I am using my mouse to select the layout class and then typing a closing bracket to create the associated closing tag. Note that the property is in the Spark namespace. Within the layout tags, I am creating an instance of the basic layout class. Note that I am typing a / and then the closing angle bracket to denote that this tag instance represents both the opening and closing tag. From an object-oriented programming perspective, you would say that the application class has a property named layout whose value is an instance of another class, basic layout. You will learn more about object-oriented programming in the last video of this day. When I save the file and run the application, you can see that the application looks exactly the same, since by default the application container already uses the basic layout class to lay out its children. The horizontal layout class lays out its children in a single horizontal row. Since its focus is simply on horizontal display, it ignores all x and y properties defined on the children. The height of each row is the height of the tallest child, and each child calculates its own width by default. Back in Flash Builder, I am changing the layout class to horizontal layout. When I save the file and run the application, you can see that the x and y properties that are set on each child component are ignored and that all content is laid out horizontally. This includes the employee directory title, since it is just another child of the application container like the employee display custom component instances. Note that the height of a row is the height of the tallest child and that each child calculates its own width. The vertical layout class lays out its children in a single vertical column. Since its focus is simply on a vertical display, it ignores all x and y properties defined on the children. The width of each column is the width of the widest child, and each child calculates its own height by default. I am returning to Flash Builder and updating the layout class to vertical layout. When I save the file and run the application, you can see that the children are now stacked vertically. The tile layout class is a little more complex than the other three layout classes. It lays out its children in one or more vertical columns or horizontal rows based on a property named orientation. The valid values for the orientation property are columns if you want a column layout and rows if you want a row layout. Row is the default orientation. All cells in a tile layout have the same height and width. Both values are based on the tallest and widest child, respectively. I am changing the layout class to tile layout. When I save the file and run the application, you can see that the application's children are laid out in a tile configuration with the employee directory text as the first element in the tile. Because this first child is so wide, it is forcing the width of the other children to the same size. Layout classes can be applied to many components, but in this video I will focus on using them with containers. Containers are essentially rectangular regions of the Flash Player drawing surface. They are also part of a hierarchical structure of visual objects, since a container can hold other components, including controls and other containers. Already in this video, I have used the term child to refer to the content within the application container. You saw that the layout classes control a container's children, and this includes the child's size and position. You will learn the basics of component layout in this module, but be sure to watch the videos on day 4 that continue this discussion of component display and layout. There are 7 available Spark containers that are separated into 2 categories. The group and data group containers are containers without any visual skins applied to them. If you know that you simply need a container to hold content, but it does not need a visual skin itself, then you can choose either the group or data group containers and save the overhead of initializing any visual elements. The 5 containers that can have visual skins are Skinnable Container, Skinnable Data Container, Panel, Application, and Border Container. Of those 5, only the Panel container has a default visual skin. The other 4 require you to add styles or apply a skin class to them to give them a look and feel. Skinning components is discussed in depth in a later video in this series. The data group and skinnable data container are also both discussed in later videos. Until that point, I will focus on using the group, panel, application, and border container components. Remember that my application currently looks like this. It is using a tile layout class, which is unfortunately including the employee directory text field. As I mentioned earlier, the group container is a very low overhead container that is not skinnable. As its name implies, its job is to group all of its visual children together. Remember that the actual layout of the children is dependent upon the layout class that you assign to the group container. I am changing the application layout class back to vertical layout and then adding a group container around the 4 custom component instances. Remember that my methodology likes me to indent any nested elements, so I'm highlighting the components and hitting the Tab key to indent them. I am also uncommenting the additional 4 custom component instances, which I also want to move within the group container. I'm going to highlight them all, and then holding down the Alt or Option key, I'm going to use my arrow key to click up so that the content is placed within the group container. You can see the group container got moved down here. Again, I'm going to highlight all these elements and tab them in so that I can visually see that they are nested. I am adding a layout tag property set to the group container and setting its layout class to tile layout. Note that there is now a layout class defined for the application as well as this new group container. A container's layout setting affects only its immediate children. That means that the application layout, currently set to vertical layout, will only affect the employee directory, text, and the group container. They will be vertically stacked on one another. The tile layout class instance set in the group container will only affect the 8 nested employee display custom components. When I save the file and run the application, you can see that the application is displayed as expected. The employee directory text and the group containers are vertically stacked, and all the employees are laid out in a tile configuration. In the earlier video about Spark and MX components, I emphasized that the Spark architecture largely separates the visual styles and skins of a component to a skin class file. However, if you have some basic styling needs, you can implement it with the border container class instead of a skin. This class defines a set of CSS styles that controls the appearance of the border and background fill for a container. The border container class is a child of the skinnable container class that you place around a group container. In Flash Builder, I am selecting Help, Flash Builder Help, to open the new Adobe Community Help window. Here in the Help files, I am searching for Border Container and selecting Local Help. I'm also selecting the ActionScript 3.0 language and component reference. Now I'm clicking on Border Container and then clicking on Styles. Here in the Help files, you can see that this class contains many styles that you can apply to your containers. Here's the current application again. I want to place a border around all the tiled elements. Back in the code, I am adding a border container instance around the group container. As before, I am highlighting the nested code and hitting the Tab key to indent it. In the opening border container tag, I am adding the border color property with a value of pound 0B85B7, which is a shade of blue, a corner radius property with a value of 8, and a border weight property with a value of 4. When I save the file and run the application, you can see that the employee display components are now surrounded by a rounded rectangle. For your next step, watch the video titled Adding Scroll Bars.